Hello, in this lesson, I would like to go over some selected questions, especially some of these questions are selected from your exams. For example, when we ask about the domain and range for these functions, such in the previous lessons, I have systematically talk about the how and why. But if we just look at the answers itself with understanding, see if we look at the domain and range for function, right? So for example, sine x, right? Sine a, right? We know the domain is all real numbers. And the range, right? We have different forms about the range. The domain is all real numbers. And I trust that everybody knows that, right? We've done the graph and the picture shows that, right? The picture shows why the domain is such and the range as such. Okay, so here I'm attaching the graph. So you can see we are told, from by the graph, and we have many lessons to talk about this, and I will graphed the function many points. Okay, so I'm going to attach a graph here, sine x, hold on, to enhance your understanding of it. So sine x, right? And in the previous review material, we talk about how, from the definitions perspective, right? From the definitions perspective, why the domain is such, range is such, right? So the graph is here. So the graph tell us, right? The graph tell us that we can have, the graph goes in both directions. If you draw arbitrarily any vertical line, you're gonna cross the curve somewhere, right? So that's why the domain is all real numbers and the range is between -1, because the entire curve is bouncing between -1 and +1. Okay, and there are three different forms. There's three different forms. The first form, we've been talking about this, is that it's between -1 to +1. Okay. And there's another form. The other form is in absolute value form, which is the absolute value of sine of any angle is less than or equals to 1. And the third form of the range, of course, is a bracket. I say this is the least useful, but it is useful. I mean, don't get me wrong. It is still useful in its own way. And for cosine x, it looks like a shifting of sine x. Okay, it looks like a shifting of sine x. So we're gonna put it here, that's the cosine x, right? We're very familiar with this graph now. It's just what you see from the graph, right? A picture tells a thousand words. We're really not asking you to tell 1,000 words about a picture, but you need to be able to tell this information, right? And cosine of a function, that's everything actually the same for sine and cosine. And of course, this will be cosine and that's cosine, right? That's a domain range perspective. How about tangent? Okay, tangent, you know what? I should make three forms. I should make this three form written differently. Okay, so that will look better and take less space. All right, so I'm going to do this. 3 rows, 1 column. Let's see if that will work. Yep, this will be better. Okay, so these are the 3 forms. Okay. And for cosine, there are also these 3 forms. Okay, all these 3 different forms. So this is a cosine. This will look more compact. Okay. Whoops. I put it in the wrong place. Sorry. So this piece, it should go down. They should swap place. They should swap places. And this piece should go up and replacing that. Okay, that's what I intended. So this piece goes there. So the three forms of sine and cosine, they have much similarity, but tangent, the story is different. The story is different. And we have talked about why, right? It's all because of definition. It's all because of definition, right? ARD and let me try to cut this not too long, not make it too long. Okay, so the angle cannot be, so the domain for tangent is all real numbers, but odd number multiples, so pi over 2. Pi over 2. Okay, and the range is from negative infinity to positive infinity. Okay, and the graph tell us. Okay, so tangent function has a graph. Oops. What's going on here? The program confused, huh? The program is confused. Okay, so here it is. Here's the graph. You see there's a vertical asymptotes at the odd number multiples of pi over 2. Okay, so there's vertical asymptotes at the odd number multiples of pi over 2. Okay, so the picture tells us so. The picture tells us so. Okay, so let me make it just a little bit smaller. No, these things just don't line up very, very nicely because I don't know, no software is perfect. Okay, no software is perfect. So the vertical asymptotes, they're at the forbidden value, the forbidden input. Okay. And so let's look at the arc sine, arc cosine, and arc tangent. These functions are very commonly used. Maybe we should add add the cotangent. Okay, add cotangent. Cotangent, the domain is that it can be any real number, but multiples of pi. Any multiples of pi, it cannot be. And the range is from negative infinity to positive infinity. And the curve, I'm going to change it to cotangent, right? So this is cotangent. That's it. So the shape is slightly different. So the forbidden lines are, the input that cannot be are the multiples of pi, right? So now, with that being clear, let's look at the arc sine, arc cosine, arc tangent, and arc cotangent. So we should have 1, 2, 3. Let me make more columns, right? More columns. So these are the arc sine, lowercase, right? Arc sine, or arc sine written in this more modern way, even though I don't agree with it, right? Because it confuses a lot of our students, but we have to just accept their existence because they're all over the place. So this is a arc cosine. So this is a cosine arc. So I'm still asking you guys to read it as arc sine, arc cosine. Okay, so arc tan. So what's wrong with this one? Arc sine. Okay, so that changed. 10. Okay. These softwares are created for our application, but they're not always, able to do everything we want them to do. Okay, so we just have to take what we can. Okay, so make this a little bit larger fonts. A little bit larger fonts for the arc sine, arc cosine. You know what? I should remove the picture. You know what? I should remove the picture after a while. I will give you another compact version of it, okay? Ooh, I think the picture mess things up. The picture mess things up. So I'm gonna remove this column. Okay, so this is too big to manage. These too big for me to manage. What am I doing here? Okay. You know, I should do this. Okay, just forgive me for a second. Okay, I'm gonna remove this last column of pictures. Okay, you guys can see those pictures yourself. We've done them. Oh, geez. This is just so. Okay, here, remove. Okay, this is better. I'm just going to remove the last column. All right, so this is better. Okay, domain range in a compact form. Okay, so the pictures, you know, if you want to see the pictures are here. And let's look at the arc sine, arc cosine domain range just for for your convenience. I'll give you two versions as well. Okay, domain and range, row above. Okay, so the domain and range and graph. Okay, we're gonna do graph and I give you a version without graph. Okay, domain for, because we know the input for arc sine are ratio. Okay, so those ratio has to satisfy certain conditions. So this ratio, let me insert a 3-form column. Okay, one, right? Oops, my bad. Put it here because I need that. Okay, so the input X, you have to indicate that this is X, right? The input has to be between -1 and +1. Okay, and there's an absolute value form. There's an absolute value form, X less than equals to 1. And the last form, of course, is going to be from -1 to +1. As I said earlier, you have to let the reader understand which symbol is used for input. If you decide to use a heart, right? If you decide to use heart, right? Then you use heart. And these symbols has to be consistent. And this will become heart. This will become heart. And that will become heart. Okay, so you need to make sure, because the symbol tells the role of the symbol. The symbol is just a placeholder. Okay, so the range for arc sine, there's 3 forms as well. It's not from -1 to +1 for sure, right? Because if you look at the picture, okay, let me show you the picture. Arc sine. Okay, arc sine. If we look at the picture, we've seen the picture. Okay, we've seen the picture. The picture tells us the domain is from -1 to +1. The range is from -π/2 to π/2. Okay, so that picture tell us, is this picture tell us? So the picture tell us the thousands of words, many thousand words. So the domain, this symbol is in the place of input. The output, however, right, is between -π, which is a vertical span, is between negative pi over 2 less than equals to, and then less than equals to pi over 2. Okay, and there's an absolute value form. There's an absolute value form. So you put this piece, okay, so heart is just a placeholder, and that's going to be less than equals to pi over 2. And the range, of course, in interval form, and that's negative pi over 2 to pi over 2. Okay, so that's the 3 forms. For arc cosine, these are the same. Okay, but we need to make it consistent. Say here, I want to use a different symbol. I want to use spade. Then this will turn into spade. So you just need to be consistent. Okay, you can use any symbol you want, but the symbol has to be consistent. When you indicate them, you have to make sure you have a consistency. Okay, you cannot use say, oh, here I have heart, and then here I'm using heart. Well, that's going to be, nobody will understand what you're saying, right? And the range, okay, the range for arc cosine, actually, I have 2 forms for you. Is between 0 to pi. Does it have an absolute value form? It does, but I'm not going to make you guys learn it. Okay. And arc cosine curve, right? Arc cosine curve, of course, we can get it. Right? Arc cosine x. And that's going to be a picture that we've done that before. You can see this picture tells the words about its domain and range. Okay. And there we go. So we have that picture right there for arc cosine. For arc cosine. Okay, it's right here. So it tells the domain, you see, from -1 to +1, the range is from 0 to pi, from 0 to pi, right? You see just a little over pi, just a little bit over pi, 3.14, right? So we've done all of these pictures. So if you guys have any misunderstanding or anything you're not certain, you go back to watch those lessons in the previous lectures. Okay, now let's look at arctangent. Let's look at arctangent. Okay, arctangent domain can be any real number. So here, and the picture tells us so. Okay, so I'm going to show you the picture in a moment, and you can get the picture very easily yourself. And here I'm just using X. Okay, and these domain, when you have domain which is all real numbers, you don't have an inequality form. So this curve is between -pi/2 to pi/2. And there's a horizontal asymptote, which we have gone over in class before, right? Right, that's arctan, right? And if you just recall what we did, right? The horizontal asymptote, right? The curve that, you know, the line that the curve will never touch, but again, infinitely close. The horizontal asymptote, hold on, I should make them broken lines. Okay, please be broken. Please be broken. There, right? See, you see the picture tells us 1,000 words. And here I'm not going to, because I don't think we have arctangent. This software doesn't produce arctangent. So I'm going to leave that for you, but I'm going to give you the domain and range. The range and domain and range is very similar to arc sine, but there's differences. Okay, so I'm going to show you the difference. So arctan, okay, arctan, say I'm going to use X just to be consistent. 10, okay, is less than, does not include equal, because -pi/2, pi over 2 to negative pi over 2 or positive pi over 2 is not in the domain of tangent. Okay, so these are the three cases. These are the three cases. Okay, so let me see if I can show you a proper picture. You know, you see so these are the domain range for arc sine, arc cosine, arc tangent, right? So how you express them, right? So we covered these before. It's just now we put them together. The next set of questions I'm going to be working with you are the selected questions, okay, from one of the midterms. Okay, these are the selected questions, but we have answers here, but now if I remove those pictures, right, for the arc functions, let me see if I can make a shorter version for you, which looks nicer. The picture just really just messed things up. I just have to make it just a little smaller, okay? Be patient with me. So here, I'm going to delete, whoops. Oh, I hate that, jeez. Okay, come on. Okay, let's see. Will that give it to me? Okay, it does. Delete. Okay, better. Okay, so this is the form without the picture, right? The picture helps us to see this. And these are the domain range for, let's make it 125%. I can show everything in one picture. I show everything in one picture, right? So this is about arc sine, arc cosine, arc tangent. And the other one we have is arc sine as a sine, cosine, tangent, cotangent, arc tangent, arc cotangent. I'm going to put you here. Okay. I'm going to put it here below, right? So arc cotangent x is arc cotangent x. There's a different way of writing it. The domain are the same. Okay. The range actually is similar to arc cosine, except that this is a less than, and this is a less than. And this is going to be parentheses because it doesn't include a 0 or pi. And of course, here is the arc cotangent. There we go. Arc cotangent. That's it. And this doesn't look very good to me. Arc cotangent x. Okay, that works. Okay, so these are the different forms you need to know. And you know, you're expected to know. Okay, you're expected to know. Okay, so now let's look at some other questions because the rest of a lot of the questions is using these facts. Okay, take one of the questions, for example. Okay. This, I'm going to make it example number 1. So sine of sine, this is arc sine, negative 4/5. Okay, what does that equal to? If you know the shortcut, you know, when we study sine, when we study composition, we know there's a shortcut, right? If you know the shortcut, it's pretty straightforward. So what are the shortcuts, right? There's 2 shortcuts. I like to just mention it, you know, since we talk about this. Okay, one is that sine of arc sine of x equals to x. Okay, so this x is a ratio. So if this ratio is between -1 to +1, I know these could be difficult to remember, right? So if you know this shortcut, and you can just apply the shortcut. You can just apply the shortcut, okay? So the answer is just going to be -4/5. And what if you don't know the shortcut, right? That's the question. So the second shortcut, I'm going to put it here anyway. But this second one has a condition. It has to be between -π/2 to π/2. 2π/2. This second x is because the location it is in, right? The second x, oh gee, the negative sign disappeared. Sorry. I'm going back to 125%. Okay. Because x is following sine, the rule determines the properties of the symbol. So this symbol x must be an angle. This angle is between -π/2 to π/2. So these are the shortcut. Obviously, this is fitting this, is fitting the first shortcut, right? So the answer is very straightforward. But what if you have forgotten? What if you don't know the shortcut? Okay, so another way to do this is that, okay, I don't know the shortcut. What do I do? Right? So if I don't know the shortcut, well, I forget about the shortcut and I'm not sure about the shortcut. In any case that the answer doesn't seem to be so easy to come by, you can always go back to the basic, because we know that this is a ratio. Arc sine takes ratio, produces angle. So we know this piece is an angle. So we're going to assume, okay, this piece is going to be an angle. And this angle is going to be where? Is it going to be in the range of arc sine? What's the range of arc sine? The range of arc sine is here. There are 3 forms, right? And because this angle is also, because this ratio is negative, therefore we know that the angle terminates in the 4th quadrant. You see, because this is negative ratio. You understand what I mean? Okay, so this is how you can use the property here. Okay, we don't know what the angle exactly it is, but we know it is an angle that terminates in the 4th quadrant. Okay, so we can see theta terminates in quadrant 4. Right? Then we can draw a picture. We can draw a picture. And this picture, okay, I want you guys, as you're watching it, don't idle. Just get a piece of paper, pencil, and draw the picture along my side. Along my side, right? So here's the picture. Right, you draw a rectangular system, and you know the angle terminates in the 4th quadrant. But what happened to the second, third? They're in the no-fly zone. There's no fly zone. Okay, so if you like, you can just cross them out. Okay, cross them out. Right, just cross them out. I'm crossing them out. Right? So it's not possible to terminate in the second quadrant with third quadrant because the range of arc sine is in the between -π/2 to π/2, and we know all of these facts. We know these facts, really, okay? And now, of course, we understand because the inverse function, right? So sine theta equals to -4/5. Why is this? This is definition. This is definition. right? Remember the one-to-one correspondence between angle and ratio, that blue number ratio, right? And here we go, we already have the answer. We already have the answer, right? Sine theta is negative 4/5 because this is theta, right? So this piece is, this is sine theta. So sine theta is negative 4/5. If you have to draw the picture, what picture would you be drawing? Right? What picture would you be drawing? What would you be doing? Right? This is going to be the what? The blue over R, right? So R is 5, the blue is negative 4, right? The blue is negative 4. And you already know the red is 3, right? So the terminal would be, even though it's no longer necessary to draw here, but you can, because I was just asking you to draw this, right? So this is 3, negative 4, that's the terminal. So you have the terminal, right? And what is the red, what is the blue? What is the red, what is the blue? Let's draw the red. I don't want to get you guys really bored, but we seem to have been doing this for all these times. Been doing this over and over again, right? So whether you know the shortcut or you don't know the shortcut, you're gonna get it if you just know how to do the basics. So that's the first exercise. Okay, the second one, okay, is a cosine of arc cosine 3/5. 3/5. Right? So if you know the shortcut, what is the shortcut I'm talking about? Right? What the shortcut about? It's about composition, right? We did those but weeks back. We talked about the shortcut. There's a shortcut. If you know the shortcut, and it's a, so if you know the shortcut, it's pretty straightforward. But if you don't know the shortcut, it's not the end of the world. Okay, so what is the shortcut? The shortcut goes like this. Okay, cosine, arc cosine of x, or this x is ratio equals to x, if this x is between what? Between -1 to +1. So if this ratio is between -1 to +1, and then this will be true. So the answer here is just 3/5. It's very straightforward, right? And the other shortcut, since we talked about this, the other shortcut is arc cosine of cosine equals to x, right? This x is angle, okay? Because the property of x determined solely by the function that immediately applies to it. So this is true if x is between 0 to pi. Right, so this is related to what we talked about way back in the lessons, that there's a piece of cosine that's inverse to arc cosine. So if you know the shortcut, the answer is pretty obvious. What if you don't know the shortcut? Well, no problem. If we don't know the shortcut, right? If we don't know the shortcut, what do we do? Well, we just go back to the basics. We go back to the basics. Right? We know the ratio is the input for the arc cosine, and arc cosine produces an angle, and where that angle is going to be between 0 to pi. You see, this piece of information will come to our rescue, right? So this piece of information will come to our rescue. So naturally, we're going to introduce this angle. We let it equals to theta, right? Whatever symbol is easy to write, right? So we assume this. If cosine, arc cosine 3/5 equals to theta, theta is going to be where? Theta is going to be in this interval. Oops, sorry. I'm putting it in the wrong place. Okay, in this interval. Okay, why? How do I know? Because of the domain and range of arc cosine. 3/5 is in the domain, and the output is going to be in the range. And as a result, by definition, right, cosine theta is 3/5. And that's the answer, because cosine of arc cosine, this piece is already theta, right? So this piece is theta, so that we're going to replace it by theta, and cosine theta is 3/5. You see? Right, so either way, you're going to get the answer. Either way, you're going to get the answer. Okay, so I'm going to put the fact that if you want to draw the picture, you can. You certainly can draw the picture. Okay. So how does the picture look like if we have this piece of information? Right, so that's going to be the red. Oops, what am I doing here? Silly. Okay. By definition, cosine theta is going to be equal to what? By definition, it equals to that red over R. So red is 3, R is 5, right? So if we draw that rectangle, if we draw a rectangular system like this, and this time, the picture is going to be somewhat different, isn't it? Which quadrant do you think it will be crossed out? What quadrant will be crossed out? That's right, quadrant 3 and quadrant 4, right? Those are the no-fly zone. Those are the no-fly zone. So, I'm drawing the picture, and I trust you guys are drawing that picture along my side, right? There we go. So which quadrant will be the no-fly zone for cosine? We all know that, right? That's going to be, so let's cross them out. Let's just cross them out, right? So this is, you go ahead to do the crossing. No-fly zone crossed out. There we go, right? And the 3/5, so the red is 3. This is like, it looks like 3, 4, 5 triangle, right? 3, 4, 5 triangle. And we know the red. So we know the red. So we know the red. And what will be the blue? Right, that's the red. The blue looks like it's gonna be, the blue is gonna be what? The blue is gonna be 4, right? 3, 4, 5 triangles, right? So academically, how many triangles are you gonna be dealing with? The special triangles, you know, 30 degree, 60 degree, 90 degree, 45 degree, 45 degree, 90 degree. And the other triangles like 3, 4, 5, 5, 12, 13. And any triangle you can deal with once you understand how to deal with these triangles. Okay, and the terminal, of course, let me draw the terminal for you. The terminal will be right there, right? So whether you have the shortcut with you, or don't have the shortcut with you, it's no problem. It's no problem. Okay. So number 3, the example number 3 we're going to work with is arc sine of sine of negative pi over 4. Negative pi over 4. Okay. If you remember the shortcut we just talked about earlier, one of this is fitting to the shortcut. The second one, right? The second one, because the angle is inside this interval. Therefore, if you know the shortcut, the answer is right there. The answer is just negative pi over 4. And what if you don't remember? Once again, right? What if you don't remember? No big deal. If you don't remember, right? So this is applying shortcut. Another way, if you don't remember the shortcut, no problem at all. No problem at all, right? So what do? We do it from inside out. How do we do it from inside out? How do we do it from inside out? Right? You work on sine negative pi over 4. Negative pi over 4, you work the ARD. You work the ARD. Let me see if I have that unit circle with me. Okay, many of you do have that unit circle in our mind. And I think I have it somewhere there, right, in this file. So I'm just going to bring it with me, right? We have this unit circle here. When we are dealing with this sine negative pi over 4, and we measure the angle from where? From the standard position clockwise. Boom, that's the terminal. And you find the blue number. That's negative root 2 over 2, right? So you just do it from inside out. Sine inverse, I'm sorry, not sine inverse, arc sine. You see, that's my bad. Okay, I asked you not to read it that way. Sine negative pi over 4, you find the terminal, so that's going to be negative root 2 over 2. Negative root 2 over 2. Okay, and what's arc sine? Negative root 2 over 2. That's going to be, of course, negative pi over 4. Right? So once again, that no-fly zone, all of that thing is coming into your, which is from our study. And also this piece is what's going to be useful for us, right? Because we're at the end, we know that when you look at this expression, right? And whatever this is, we know this is going to be a ratio. So arc sine of something, if the ratio is within the domain of arc sine, right? Then the output is going to be between negative pi over 2 to pi over 2. There should be no question about it. Okay, because if you get an answer outside that interval of the range, and you're for sure you're going to be wrong. So we have lots of tools at our disposal. Okay, we have lots of tools at our disposal. Okay, so let's look at example number 4. Okay, and this one gets a little bit more interesting. Cosine, this is arc cosine here, right? And then we have cosine of negative pi over 4. Okay, you have to trust me that I'm making this, I put this question there for a reason. For a reason. If we're speaking about shortcut, okay, let me put all the shortcut together, okay? This is a shortcut for, okay, there's a shortcut here. There's a shortcut for cosine, arc cosine. Okay, so I'm bringing these shortcuts together. I mean, I don't expect you guys to remember these shortcuts, but the more you try to apply it, the better off you're going to be. And here, okay. So here there's 2 shortcuts you might be thinking of. Okay, and these two do not apply. And then you look at these two. Do they apply? They don't. Why? Because negative pi over 4 is not in this interval for the shortcut to apply. Okay, so this, the only possible shortcut that may apply. Okay, so let me put it here. Okay. Shortcut doesn't apply. Doesn't apply. So if you're thinking about shortcut, you know it doesn't apply. Then what you do? There are a couple ways to do it. Actually, I will show you. First of all, you do it from inside out. Okay, so method 1, you just do it inside out. Okay, inside out. That's what you do. So layer by layer, from inside, right? So the arc cosine is still waiting outside. So you're going to work on the inside. The inside is a cosine negative pi over 4. So you're going to, what are we going to do? You're just going to turn, you just measure the angle, which is going to be clockwise, right? Clockwise. We measure the angle clockwise, the terminal is here. And what is a cosine negative pi over 4? Clockwise, the red number, √2/2, right? √2/2. So the inside gave us a ratio, and that ratio is √2/2. Then arc cosine of √2/2, right? For the no-fly zone, cross it out. So you have the ratio of √2/2, and the angle, of course, is going to be pi over 4. Pi over 4. So this is one way to do it. I do want to show you another way to do it, because you might like this one better. You may like the second way better. Okay. The second way may be preferred. Okay, the second way may be preferred because it's even easier. It's easier. Why is that? Why is that? I'm going to show you. Okay, here's why. Cosine is an even function, isn't it? Cosine is even function. So I'm taking arc cosine outside. Cosine negative pi over 4 is the same as cosine pi over 4. So opposite input produce the same output. So cosine negative pi over 4 is a cosine what? Pi over 4. Okay, and this time we can apply the shortcut. This time we can apply the shortcut. So applies. So this shortcut applies. If the shortcut applies, what does that equal to? Because the pi over 4 is inside this interval, right? And there we go. The answer is also pi over 4. Okay. So these questions, exercises intended, designed for you to apply. Shortcut, if applies, if it doesn't, if the shortcut does not apply, you just have to apply the basic principles, which ARD, DRA, so on and so forth. Okay, so let's look at another one, example number 5. Okay, and this time we have arc sine. Arc sine, right? And sine of 3 pi over 4. 3 pi over 4. And of course, now we like shortcut, right? Does a shortcut apply? This only shortcut that looks like may be useful. It doesn't apply. Why? Because 3 pi over 4 is outside, right? So too bad, does not apply. So what can we do? Then we just do it from inside out. We just do it from inside out. Okay, so we have here. So the shortcut doesn't apply, right? Then what do? We do it from inside out. So we have the unit circle. We're going to measure 3 pi over 4 ARD. Right, how do we measure ARD? How do we measure 3 pi over 4? From standard position, counterclockwise, we terminate here. And the blue number is √2 over 2, right? Right? So the blue number is √2 over 2. So here we're going to replace this number by √2 over 2. Now we get arc sine √2 over 2. And arc sine √2 over 2, we know that what is a no-fly zone? The answer has to be in the range of arc sine, right? So this basic facts will have to apply. These basic facts apply. So the answer you are expecting, the answer we are expecting in this case, we must understand is dictated by the range of arc sine, which is in 3 forms. The answer is going to be between negative pi over 2 to pi over 2. Okay, and of course you understand that no-fly zone, we've done this over and over again, right? So if I use this unit circle here, you would just say, okay, I'm going to use that unit circle, right? Crossed out, no-fly zone. √2 over 2, the blue number and angle, they're 1-to-1 correspondence. So this angle has to be what? The answer has to be pi over 4. Has to be pi over 4. Okay. So in these cases, you cannot use the shortcut. You cannot use the shortcut. Okay. The next one. This will be example number 6. Okay, so this time is arc cosine. Arc cosine 3 pi over 4. 3 pi over 4. And you might be thinking, do you think that shortcut could apply? Does a shortcut applies? Okay, does a shortcut applies? So then you say, what shortcut? Which one, right? And then you bring your shortcut closer to you. Which one is most likely to apply? This one is not going to apply. And this one, does it apply? Yes, it does. Because 3 pi over 4 is between 0 to pi. So this one, the answer is very straightforward. Otherwise, you still just do from inside out, right? You would do from inside out, okay? So shortcut applies. So that shortcut applies. That's nice, right? So it's nice you recognize the shortcut that applies, okay? But what if you don't know, or you forget, or you are confused? What do you do? In that case, you should still bear in mind that these basic facts about arc sine, the no-fly zone, etc., etc. Okay, so another, if the shortcut doesn't occur to you, you should still know these basic facts. Okay, that's why These are the centerpiece. These are the centerpiece. And what you do, you do it from inside out. You do it from inside out. You know the no-fly zone. And before long, you should recognize it, right? So let's do it from inside out. Okay, we do it from inside out. So the inside is cosine 3 pi over 4. So you measure the angle counterclockwise 3 pi over 4 from the unit circle. Right? Right here. Huh. I know these pictures kind of mess things up. Okay. Okay, so we measure that angle counterclockwise, then we terminate here. That's the terminal. If you like, I can just draw it for you. Here's the terminal, right? And look for the red number. Look for the red number. And that red number is negative root 2 over 2. Negative root 2 over 2. Okay. And after that, then you say, what is arc cosine negative root 2 over 2? Well, we know the no-fly zone, don't we? Cross out. Well, it turned out to be what? It turned out going to be 3 pi over 4. Right? Because the red number ratio and the angles are 1-to-1 corresponding to each other. All right. Okay, so let's keep moving forward. Let's keep moving forward. Okay, so we got a shortcut. Okay. And so there are a couple more, right? So example number 7, we have a arc sine. We have an arc sine of negative 5 pi over 6. 5 pi over 6. Does the shortcut apply here? Probably not, right? Okay, you can write this way too, arc sine. Okay, arc sine. Does the shortcut applies? No, it doesn't. For that shortcut to apply this time, where our question is that that shortcut applies. Does it apply? It doesn't, right? This one is the closest, but negative 5 pi over 6 is outside this interval, therefore it doesn't apply. So I'm just going to put a note here. It doesn't apply. Does not apply. Well, if it doesn't apply, you can do it from inside out. This is not the only way, actually. This is not the only way, okay? So you just have to measure negative 5 pi over 6. Okay, so I'm going to bring these away from me. Okay, negative 5 pi over 6. How do we get sine negative 5 pi over 6? We're going to measure from standard position clockwise. So we're going to terminate here. So what the blue number? The blue number is negative half, right? So this blue number is negative half. So we're going to replace this number by negative half. Negative half. Okay. And the next step, arc sine of negative half. We're dealing with arc sine negative half. And what do? No fly zone, right? What is the negative half? Right here, the blue negative half. Because in this, between negative pi over 2 to pi over 2, negative half corresponds to negative pi over 6. So the final answer is going to be negative pi over 6. Does that make sense? You can see we're constantly working with those things. Okay, we're constantly working with those things. Okay. Other ways applies if you want to explore those. Okay, so I'm going to do 2 more examples. Example number 8, right? This one is arc cosine. Cosine of a negative 5 pi over 6. Obviously, the shortcut does not apply, right? The shortcut does not apply. Why? This shortcut, if you even think about this shortcut, it doesn't apply. So the general theme is that you have to be ready to work it from inside out. If you can apply shortcut, those are the special circumstances, and it happens, but doesn't happen all the time. Okay. And it doesn't apply, therefore, you just have to do it from inside out. And here, I noticed that the cosine is and what? Is an even function. So cosine negative 5 pi over 6 is the same as a cosine pi over 6. And now the property applies. And this time it does applies. Okay, of course, you can also work the inside out. Okay, measure the angle clockwise, get negative pi over 5 pi over 6 to put the negative number. You're still getting the same answer. So there's more than one way to do it. And in this case, your answer is 5 pi over 6. Okay. Now, example number 9. Okay. So we have arc sine of sine sine 7 pi over 4. So 7 pi over 6, sorry, 7 pi over 6. Does shortcut applies? No, it doesn't. Okay, it does not apply. Too bad. But we know what to do, right? We know what to do. Does not apply. Okay, and then what do? We just do it from inside out. Okay, of course, even from inside out, this is not the only way, right? So you measure the angle from standard position. You see ARD is constantly used. So that ratio is -1/2. -1/2, right? And then we're dealing with arc sine. When we're dealing with arc sine, what happens? No fly zone. So for -1/2, arc sine -1/2, there's only one angle, which is going to be what? -2 pi over 6. -2 pi over 6. Okay. Let's see what else I'd like to go over. Matching points with the graph, which was on midterm exam for one of my trig classes. You guys should refer to the pictures we graphed. Okay, if you have questions, then please let me know. I can work something out for you this weekend. Because we've done in great details about those graph. Okay. The next one, I think what I can go over is the matching the fraction with matching the, there's this question. Okay, so I'm going to put it out here. Okay, so it's it's not, it's just easier to see the question. Okay, so example number 10. This is example number 10. So what we want you to do is match the left with the right so that they are equal. This is a purely algebraic practices. So we're gonna have 4 rows. Okay, so on the one side is 5 pi over 6. 7 pi over 6. 7 pi over 12, sorry. And the other one is 22.5 degrees. And the other one is pi over 12. Okay, and the left-hand side is half of pi over 4. The next one is pi over 3. Minus pi over 4. And the next one is pi over 3 plus pi over 4. So I'm just have to change the sign. And the last one is pi over 3 plus pi over 2. Okay. So we match so that they're equal. So maybe I should do this, right? I should do this. So that will make it easier match. So how do we do it? How do we work it out, right? You can work from left to right or right to left, right? So starting from the first one, it looks like there's 1 degree here, right? So, and half is, and pi over 4 is 45 degrees. So this is going to be 22.5 degrees. So these two match. These two match, right? What else? 5 pi over 6. So how about we just work out these fractions, right? So this first one is done. Let's work out these fractions. Okay, we're gonna get common denominator, right? So pi over 3 minus pi over 4. So pi over 3 minus pi over 4. And we want to get the same denominator, right? So for this one, we're going to have to multiply 4 over 4 because the common denominator looks like it's going to be a 12, right? So that's 3 over 3, right? And right here, now we get 4 pi over 12 and minus, and this is going to be 3 pi over 12. So now in the end, we keep the denominator, which is 12, and 4 pi minus 3 pi, that's going to be a pi. So which one does this match? This match pi over 12. So these two match and these two match. We have 2 more left, right? And we have a pi over 3 plus pi over 4. So, I mean, to me, I already see the answer, right? I don't know if you do too. It's just the process is going to be similar, except this piece is going to be adding. It's going to be adding. It's going to be adding. So this is going to be 7 pi over 12. And of course, you already know which one, the last one to match. But if you like to work it, just to work out, just to check, to improve your algebraic skill, right? Take this one, you're going to find common denominator, right? We're going to find common denominator. That's going to be 6, right? Common denominator is 6. So how do we make that match? How do we make that match? So this one needs a 2. So we're going to multiply 2 over 2. And this one needs a 3. So we're going to multiply 3 over 3. Anything times 1 stay the same. So here you're going to have 6. Now it's 2 pi plus the second one is going to be 3 pi over 6. Right? So in the end, we're getting 5 pi over 6. 5 pi over 6. There you go. So now we finish all these operations, right? And let's make the match, right? So these two match. These two matches. And I'm just using different colors so we don't get confused, right? So these two match. Oh no, I made a mistake, sorry. The yellow one, okay. Purple, these two match. Okay, my bad. Almost made a mistake. And these two match, okay. I think this is enough for this lesson. Okay, first, yeah, I'll do another one another time. Thank you for watching.